Good afternoon, everyone. I'm Priyanshu. I'm a co-founder at Epicue. We're a climate adaptation and resilience company protecting workers from heat. Can you remember a time when you felt uncomfortably hot? Now, in that situation, if you had to dig a hole in the ground or shovel gravel for hours on end, that would sound quite difficult, wouldn't it? This is the daily reality of workers in labor-intensive jobs, such as mining or construction, across the world, where high heat leads to significantly increased error rates and hence is a contributing factor in 92% of exertional incidents that happen on site. One such incident can cost an employer or a company at least 63,000 pounds. But what about the workers? At just 1% dehydration, an individual can feel up to 12% loss of productivity and focus, which is detrimental to their work. Now, this effect compounds exponentially, with 4% or upwards of 5% dehydration being life-threatening. Mechanisms that exist in the market currently look at environmental heat metrics. We've identified a dire need for a personal understanding of how our bodies are reacting to these hot environments. And hence, we've built a fire alarm for human felt heat. We're building a personal protective equipment that is low cost and helps the workers fight against heat stress. The device notifies a user about their dehydration status while informing better hydration habits. Powered entirely by the wearer's sweat, the data is private to the user for unsupervised care. Epicue is a two-part intervention with a permanent casing that houses the electronics and the display that we sell as a one-time purchase to our customers, alongside a subscription model of a recyclable sweat patch that needs to be utilized in order to use the device. We aim to sell it directly to construction and mining companies that employ workers on site. Alongside worker welfare and safety, Epicue also promises protection against heat stress damages as well as productivity losses. To put these facets into perspective, a mid-sized mining company in South America with 500 workers, by utilizing Epicue, can save upwards of £2 million a year. A global heat-stressed market of 321 million workers gives us a market of 6.2 billion to target. Coming on from that, we've identified a much more focused market of South American mining companies, specifically in Argentina, with a good track record of employee health and safety to start with. By being low cost, accessible, and easy to use, Epicue stands at its unique position in the market, with its nearest competitors being several times more expensive. I'm Priyanshu, and along with my co-founders, Orestes and Seb, we're an award-winning team of designers and engineers from Imperial College London and the Royal College of Art. As we progress further in our journey, we'd be onboarding more advisors. So if you're interested in what we're building, please come talk to us after the pitch. We've had the opportunity to be a part of several accelerators where we've gained mentorship and technical knowledge to progress our product further. We've showcased our design in several international design competitions as well as exhibitions. Up until now, we've taken our company from a spark to a testable prototype while building business relationships in the field, gathering letters of intent from mining and construction companies to test forward. That defines our next steps, where we will pilot test our product in the coming summer, finalize our MVP, and take it forward for patentability and patent considerations. We firmly believe that in the face of these rising temperatures, safety isn't a luxury, but a right for all. And with that, thank you. We'd be happy to answer some questions.
Priyanshu, well done, and we welcome your team members on stage for questions now. And let's start with one about the focus on this device being powered by sweat. Why is that? Well,
Essentially, the standard in the market right now is core body temperature, which is invasive to measure and also very expensive. Epicue utilizes sweat because in our application fields it is easily accessible. It is highly correlated with blood in its biomarkers, and it is a much easier thing to track in our applications.
Leading on from that, a question in asking whether existing smartwatches, for example, Apple Watches, could implement this with software feature builds and therefore pose a significant competitive threat.
So what's happening with the smartwatches and devices similar to that, and we have competitors in the field that work on energy-intensive devices like that, is that they're more expensive to manufacture, and they take that data and they provide it to the employer for employee management of sorts. Whereas we've identified gaps in the industry where most of the hydration-related or heat stress-related management systems work on self-reliance, and hence we're building something for the employees on the field. So the data is kept private and it's extremely low cost, and it's not built in a way where you can take that data out to other places.
How do you achieve such low costs? What is your profit margin?
So essentially, we're utilizing microfluidics and very rudimentary electronics in how we're building this product, which has an initial startup cost that's slightly higher. But after that, within our manufacturing pipelines, it gets significantly much cheaper. In terms of the profit margin and the final details about that, since we're still setting up all our supply pipelines and finalizing what the product is that we'll then later commercialize, we don't have a very clear idea on that, but we'll develop it as we move forward.
Which mining company in Argentina is on board for your pilot?
So we've actually done a very initial pilot with a construction company in Hong Kong, but the companies that we have in South America that we're in talks to get LOIs from are Rio Tinto and Antofagasta Minerals. Yeah.
Okay. Without policy support, how would you convince companies to pay for this technology when the cost savings aren't very tangible, productivity cost savings that is? Is this a known problem?
There are three things I can say about that. So the first one being there's a lot of traction around employee safety in the sort of face of rising temperatures. So that's gaining a lot of traction, and companies are under a spotlight to sort of bring forward certain changes that might ensure that. Second, legislation is oncoming, whereas we've seen certain countries take up certain new legislative measures that look at enforcing insurances around heat-related accidents a bit more. And we have an in-house cost-benefit analysis calculator that we utilize in our conversations, that we take into consideration the amount of employees they have, in what months would they be working, and the losses they might incur over time due to productivity or injuries that might happen on site. And we use those as measures.
Brilliant. Another question asks about the lifetime of one smart band. What is it?
So the lifetime of the permanent casing that's housing the electronics and the display, we're not entirely sure about that, but it could last any time from maybe 1.5 years to 2 years, which is what the limitation is the display that we're using. Wherein the sweat patch that we're using has to be pushed in every shift that an employee is on site. That's why it's giving out in a subscription model to the customers that we deal with.
Fantastic. That brings us to time. Well done. Thank you.
Thank you.